Hello friends, welcome back to the bench. Today we're going to take a look at a voltage controlled lathe, mini lathe, around 35 bucks on eBay. It actually works not too bad, but since it's voltage controlled, you need to kind of switch it to all the way to 24 volts to turn it on, then reduce it to 12 volts to work on it. And what happens when you give it suddenly high voltage, and this is not an induction motor, this is the regular not brushless motor, the brushed motor. So it's got a lot of torque when you suddenly give it voltage. So what happens? You've probably seen it on the intro. And yes, I'm recording this a few days later because I had a black eye from it. By the way, always use eye protection when working with these, no matter how small they are. They are still capable of doing some damage. We're gonna take a look at this one, and we're gonna build a little PWM controller, so we don't lose any more eyes or don't get any more black eyes. All right, let's take a look. Okay, so this is a little piece of wood, a little piece of branch that I found outside. This is kind of a good thing about living in Wyoming. The wood is just there. You walk outside and it's there. So first I'm going to mark the centers roughly, and I figured I'm going to use the hammer to kind of lock it in place. And by using the hammer, I think I may have damaged the bearing a little bit. But it'll work anyways. So the chisel I got with it, as you see, very tiny, but the machine won't start. This is my first try. Before I did the dry test. Now my assumption is that I damaged the bearing, and now there's too much friction. That's why it can't start. But to start it, as I said, if there's any load on it, you need to start it with high voltage and then reduce the voltage once it starts turning. Yeah, it's turning nicely when it doesn't have any load, but as soon as you put some pressure on it, it has problems. Yep. So the soft start was initially the first thing that I wanted to do on it, but now I'm just gonna work on that bearing, just hitting it from the other side. Yeah, it did start this time, but I think I did increase the voltage. It gets a lot of vibrations, a lot of screws became loose very quickly after I started using it. You can see that the screw on the back started unscrewing itself, but as you can see, it didn't explode. It's technically working. Initially I thought this wouldn't work because those two elements are not aligned, those two holding the chuck and the opposite element. They're misaligned by a good few millimeters, so I thought this wouldn't work at all. Now you can see how all the screws became loose after that first test. So this is rather dangerous because there's only two screws and they don't have the proper washers to prevent them from loosening up. But after tightening it, I used it for many hours and it never came loose again. It doesn't really have the ability to be screwed into the bed, screwed into your desk. So later I used a clamp to kind of clamp it down, but it has rubber feet, so you can't really clamp it firmly. Overall, as you can see, this is nicely turned element. It broke, again, but I'm probably using, well, first of all, I'm using like really crappy wood, but I'm probably putting too much pressure on the both ends, and that's what causes it to break like this. The chuck that it came with, it's not the best. Maybe if you have high quality wood. This is another branch, also some reclaimed wood, and this one actually came out really nicely. This must have been a little harder wood, um, but most of the trees around here are pine and basically softwood, so it's hard to just find a piece of oak over here. But it looks very nice. It didn't take too long, and of course I burned the chisel on it. So ever since this piece, that chisel that the machine came with, is no longer sharp, so it takes significantly longer to turn elements, especially when the wood is a little harder. And some linseed oil to give it a little bit shininess. And it doesn't look too bad. Now let's try a little bigger piece. And as you can see now, I clamped the machine to the table so I can work easily. You can still see plenty of vibrations, but once you get it started and reduce the voltage to 12 volts, you can even put a little bit of pressure on it and it doesn't slow down. So it has pretty good torque. Unfortunately, it's like the motor drives the shaft directly, so there's plenty of vibrations, and you really need to be careful about putting pressure on it, depending on the wood you're working with. Just a little bit of time, a little bit of patience, and you can turn beautiful materials on it, especially when you work with good wood. That misalignment doesn't seem to have any effect. The pieces can be turned relatively well. Yeah, it's a little pain to move this little plate, especially the screw is on the inside, so you need to stop the machine before you can readjust the tool position. But the size is not big, it's just few inches that you can turn, and about 42 millimeters would be the thickest piece of wood that you could turn on it. It's not exactly, this is definitely a machine for DIYers. This is not something that you just buy and you can use it right away. Although this is how I'm using it right now. I haven't done any modifications to it yet. Just testing it. And it seems to be working very well. Also, in the hands of someone who does that for a living, the results would have been much better than mine. I have very minimum experience working with lathes and only with wood. I've never worked with metal lathe. But this one would not be capable of turning metal. I would not expect it. So this is the piece that will give me a black eye. As I said, it's always good to wear eye protection. But for some reason I didn't do it. Well, actually I don't have any eye protection, so maybe that's why. The piece of wood is not heavy, but moving at this speed, this lathe goes up to 7,000 RPM. That's maybe not mind-blowing speed, but it's fast enough to do some damage. And if it actually hit me in the eye, that would have been not too great. You just need to find a good position for your tool. Just kind of feel the tool, what's the best angle that it's gonna catch the wood. You don't want to press hard to kind of force this effect for the wood to disappear. For this size, it's really stable. I was surprised. This was probably the third or fourth element I was turning on it, so I already had a little bit of practice using this little guy. So it's going a little better. My first try on it was not going that great. Well, at least a lot worse than this one. Yeah, and it's starting to look, obviously it needs a lot more turning, but here because it already lost, it caught a little bit of wobble. This is probably what caused the accident. Maybe not this one, but the second push. If you push it too hard with this wood, if it was oak or a walnut or some hardwood, that probably wouldn't have been an issue. But with this is some kind of pine, some kind of mountain wood, so it's not very dense and it splits very easily. So if you just push those elements into the opposite sides of it, then obviously you're risking splitting the wood. But as you can see, it's still holding very well. I'm even using a little bit of pressure, doing that one little hole over there, and I'm removing a lot of material at this point. You can see how those little screws hold, they keep dancing because of all the vibration. Once you clamp it to the table, it's actually not too bad. It's still not very stable, but it's a lot better than just holding it. But what's great about it, you can actually just put it on your lap and hold it with one hand and use the chisel in the other hand. I did it, and yeah. So it's, as long as it has the speed control, you can do a lot of cool stuff with it. Unfortunately, the speed control that I have at the moment is on the transistor that doesn't deliver much power, and it dissipates a lot of heat. I even had to put it in a bucket of water. The heat sink was in the little bucket with water to take away some of that temperature, and the machine lost a lot of torque. So I'm still waiting for IGBT transistor that I'll use for this. That's why I made it in a way that I can easily replace the transistor. It's all kind of a spider solution. Everything pretty much soldered in the air, but it works. Yeah, and it's starting to get nice shape. and that's the last part of it that is not center. What do you call it? It's not even. It's not aligned. So once that is done, the element is more or less done, then we can just work with it, work with a sandpaper or files. And files is what I prefer to use before I start sanding. But you could also use like 120 grit sandpaper. It would do pretty much the same thing. So I imagined this would be like kind of a handle for something, so I wanted a little round finish on that side. So I want to remove a lot of material over there, and that's probably what also contributed to the accident. Yeah, and you can already, did you see that? Before I turned it off, it already started wobbling a bit. I didn't notice that. I just see it now. So it was already ready to be blown out. And now, yeah, there's the wobble, and there it goes. Luckily that small piece hit my face, not the big one. Well, that's what happens when you don't wear eye protection. Okay, I guess the piece is done. So now I figured, yeah, it's gotta be controlled. So my first proof of concept was on IRF 520. I think it's like 10 amp at 30 volts, the field effect transistor. A very popular, very cheap one. So as long, you can see that it does work, but as long as you don't put any load on it. When you start actually turning, then the transistor goes short. It's taken, you can barely see, but it's taking around 700 milliamps at about 14 volts. So that's the proof of concept. It can be done very easily, but as I said, as soon as you put some load on it, this transistor goes short. And that was something that I was expecting, so that didn't surprise me at all. At that point I already ordered a proper transistor to control such load, and such transistor is IGBT. It's basically a module of transistors, and it allows like huge current to flow momentarily. So it's perfect for driving motors. And in these motors, remember that even if you're driving it with 12 volts, you're probably experiencing voltages, spikes of 30 volts. So it's better to pick a transistor that can withstand at least twice as much voltage as you're using. Mine that I ordered was is for 400 volts, and I'm going to be controlling it with around 50 volts. When controlling it with PWM, you need to use much higher voltages than what the motor says, because you're never gonna drive it directly with direct current. It's always going to be pulses, so it's better to use higher voltage. But the higher voltage you use, the more stuff you need to worry about as far as the motor firing voltage back at you. So this transistor is a bipolar transistor. I wanted to test it. Technically it works. You'll see in a second that it does control voltage, but it's you can control transistor like this directly from the microcontroller. A base requires too much current to actually drive something that requires, the load that requires a lot of power. So as you can see over here, yeah, the voltage goes up and down, because that's how it. So yeah, it is working, but not under load. And now I'm just trying to figure out why it does not work. And initially, because I could not, for the life of me, I could not find a data sheet for this transistor. It's available in a lot of places, but no place gives you a data sheet for it. So I can't really tell what should be the base current to actually open the transistor. And it's since this is the one that I ordered for the PSU, so it was controlling the main transformer. So it should work on at least a few kilohertz, but here I'm using just 500 hertz. So this transistor is a field effect transistor. It also doesn't work that great, but it needs to be field effect transistor. You can't use bipolar. Well, you can use bipolar transistor, of course, but then you need smaller transistors to drive this transistor. There's no way to drive it from the microcontroller. And it's even worse when you use ESP32 rather than nano, as I used over here. I wrote the code for both, and I tested both, but with ESP32, I know Arduino works on around 5 volts and ESP32 on 3 volts, so you have even less energy to push to the transistor. So either way, this transistor shouldn't be controlled as I'm controlling it here. But with proof of concept, alright, let's put some load on it and see if it's going to work. Yep. So it obviously lost like a lot of torque. If I push it even gently, I can stop it with one finger, basically. So that transistor definitely does not open fully, and that also explains why it's heating so much. If it doesn't open fully, then a lot of energy dissipates on the transistor. Well, with the ability to control RPM on it, you can do very precise things. Even as you can see, this one is broken. If I attempted to turn it again, like I did previously, it would just fall out again. It would probably even break even more in that process. But having a simple RPM control like this, I can actually send it. I wouldn't be able to turn it, to shape it anymore, but at least I could finish it. And now the last test is actually using the RPM controller and actually turning. I knew this wouldn't be a very pleasant experience because, as I said, now the lathe has very little torque, very little power, because most of that power, or at least half of that power, just dissipates as heat on the transistor. So it requires a lot more precision on my side, because if I press too hard or have a dull chisel or hold it in the wrong at the wrong angle, it's gonna be very little effect on the wood. So as you can see, I don't have it clamped anymore, and it's just kind of riding all over the place, sliding across the desk. But it's so light that it didn't really bother me, especially since I'm holding the table for the tool. Also, as you can see, I no longer have to stop it to move my table to work on the other side of the piece, because now it's no longer as powerful. So even if I touch it or grab it, it's not gonna hurt me. So it's a different kind of work now, a lot more precise. The machine obviously also runs a lot more quiet. As you can see, it takes a lot more time, and I'm using a much better chisel now, which is actually graver, but I don't use this one for actual engraving, so it will work as a chisel from now on. And as you can see, it's slowly starting to take shape. So even with that huge loss of power, I'm still capable of actually turning some wood on it. This one, obviously, this piece is a lot thinner than the other one, and with this power loss that I'm experiencing here, I probably wouldn't start turning a thicker piece than this. But it is long. It extends pretty much the maximum to the maximum length. I think there's like maybe 4 millimeters left, and I need those 4 millimeters to actually put the piece in. So this is pretty much the longest piece you can work on. Alright friends, this is the cheap eBay lathe. Stay tuned for the second video when I actually use the proper transistor, and we'll see how much torque it'll have. For now, that's it. Thank you very much for watching, and I'll see you in the next one.